Given a sample of n equals to 12 scores, how many of these scores would be involved in calculating the range? Is it 2, 4, 8, or all 12? Okay, so in your textbook you'll see that there's a couple of different formulas for range. In the last question, I had a look at the range using the real limits of a number. So there was the upper real limit of the maximum x minus the lower real limit of the, the minimum x. And then there's also, when you're not concerned about real limits, there is just the maximum x minus the minimum x. Now, both of these formulas have one thing in common. They are one number, the upper real limit of the maximum x. In fact, I think we used 24.5 in the previous question. It was a single value minus another single value, so that was 9.5. In this formula here, where we're not concerned about real limits, we're again just using one number minus another number. So two numbers are involved in this formula. Anytime you're dealing with the range, all that you're really concerned about is the outer extremes of your distribution. So you're only measuring from the highest value down to the lowest value. It doesn't matter what's happening in between. So for example, if I had a set of numbers 1, 3, and 5, the range here is going to be equals to 5, the highest number, minus 1. The range is going to be equals to 4. The same would be true if I had 1, 4, and 5 as my values. I'm still dealing with a range of the highest minus the lowest number. It's still 4. It also doesn't even matter if I had 1, 2, 3, 4, 5. Even if I have more numbers, I really just want the distance from the highest down to the lowest number. So it's still going to just be 5 minus 1 is 4. So the range only cares about the two outermost numbers in a distribution. Whether you're dealing with this version up here, which is looking at real limits of a number, you're still only looking at two values, or the actual values themselves from the distribution, the highest minus the lowest, you're only dealing with the outermost two values.